The next presentation will be made by Vivek Gupta, Assistant Vice President and Head Instrument DCM Shriram. After completing his graduation in electrical engineering from MREC Jaipur, now MNIT, he worked at Instrumentation Limited Kota from 88 to 2006. From December 2006 till date, he has been with DCM Shriram as head instrumentation for all the 8 plants at Kota complex: power plant, fertilizer, cement, chlor-alkali, calcium carbide, PVC, Fenester building systems, and Shriram Axial. Honored with Distinguished Instrumentation Professional Award 2016, India by ISA at the Automation India Week at Mumbai. Please welcome Vivek Gupta on stage.
Namaskar, sisters and brothers. First of all, let me convey my thanks to ARC for giving me another opportunity to be present in front of you. For the last 2 days, we have been hearing about the buzzword I 4.0, Industry 4.0, and so on. From the end user perspective, I am just putting some of my thoughts on how this can be implemented and what are the challenges and way forward in the process industries. We heard about tire, we heard about food, beverages, where this is coming up at a good pace. But as far as the process industry is concerned, the things cannot be changed in a day or two. It requires a lot of efforts and a lot of investment to put the company at that same pace. As the old saying goes, that health is wealth. So an industry where a lot of equipment are working, they may be right from the sensors to motors, pumps, compressors, heat exchangers, cooling towers. If these all are in healthy condition, then only we can talk about Industry 4.0. The output will come only when all these things are working in healthy condition. So I try to put up some of my thoughts over here. Many of us who are sitting in this hall have more than 30 or 35 year experience and much acquainted with this kind of a control room, where the eyes used to be always on the top of the panel, seeing what is the process parameter going on, because those were the days when we didn't have computers in front of us. Now, why this IoT is required? Let me put it in a different way. Most of the plants are automated, and we do have DCS working over there. But then, what is the need of double IoT? DCS is for controlling the process, and that is the foremost task. Old were the days when we used to have the highest production. The highest production used to be awarded, but the story is now changed. It is the productivity which is talked of. Productivity means highest production at what cost and with safety taking into the consideration. It is not like that we did the highest production, but what was the energy consumed? Were all the other processes safe? What was the energy which was consumed? These are the things which are talked of. So, in the second para, you must have been reading that we often hear the feedback, well, that's just the same thing we have been doing for decades. And though that's mostly a valid statement, after all, the end goal of running an efficient organization hasn't changed. How we are doing it has changed significantly. That is the crust of what we want to do from here. What we earlier used to have was the point data model. The information used to be rested in the control room. As we have heard in the previous talks, that a shop floor manager has to go to the plant, to the control room to gather the information and then take the decisions. But now the instrumentation or automation is just not only for controlling the plant, but it is now being used to take the decisions also. Now, here is one important takeaway. The word which we have been hearing was IoT. Here I am trying to put it in a double IoT, means in the industries. And let's be honest that before we go or expose our system to the external world, let us first cleanse our own house. Let us be within our complex and see, because it's a big mindset change. What we are seeing at present is to be shifted to the software, which we will be talking of to take the decisions. So I'm just going to show here the phase-wise how we can implement it, but initially it has to be started within the complex, within the premises. The things here are, as I was talking about, so far we have heard is the productivity has to be increased. We have to have the delighted customers. We have to have the supply chain management, inventory management, blah, 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 lot of things are there. But unless we have our basic equipment which are being there and their health is not monitored, I feel IIoT should be first used for the reliability of the equipment and their health monitoring. This will go in a long way to achieve what we really want to have from double IoT. So the sensors have to be for equipment reliability rather than controlling the process. Because for the process you already have pressure, differential, flow, temperature, all those parameters for controlling any process is already existing in the plants. We do have advanced process controls sitting on the controller of the DCS. But what about a cooling tower? How many times do people go and take the parameters of a cooling tower? In the past, there have been a lot of incidents which have taken place. The cooling tower have collapsed, and because of what? The parameters which are being taken are through a manual visit. Once in a week, once in fortnight, the vibrations, because the vibrations of the fans, the pumps, the motors, you cannot take it unless you have an online system of measuring it. And that's where I feel the IIoT should be utilized. These can be the possible equipment which we should, first of all, put them in a connected way. As of time, they all are dumb equipment. Maybe a pump, maybe a motor, maybe a compressor. We do have the parameters. Suction pressure is there, discharge pressure is there, bearing temperature is there. But what about the other measurements which are really required to assess the health of that particular pump? So the IIoT should be utilized in such a way that we should be knowing that when the pump or a motor or a compressor is going to fail. See, a sensors and software turn dumb equipment into a smart connected equipment. Now there are a lot of pumps, a lot of compressors, they are simply putting a chip. You know that there are a lot of wearable. Now, even if you are a diabetic patient, there is a term called ALP. They will put a sensor on your hand, and it will take your blood sugar levels every minute. And 15 days time, a doctor will be able to tell you what was your blood sugar level in last 15 days, and then accordingly decide the insulin doses. So this is how something, if that is there, why not to have for a pump or a compressor or a motor where you measure. Now what is happening is, we know, but the system should be able to pinpoint that particular region. Suppose it is a pump, it should be able to tell you, is it due to a cavitation? Is it due to the pump bearing temperatures going high? That reason should come. See, what is an analytics? Yesterday I was going through the Times of India. We have been talking about analytics in the last, so many people who have talked about. It was mentioning the requirement for data scientists who are doing the analytics in the last 1 year has risen by 400%, whereas the input has increased only by 19%. Just think of a process engineer, a maintenance engineer, or a plant engineer. He is interested in knowing what is the root cause of my problem. He is not a data scientist. So the analytics software which has to be put should be able to give the reason to the engineer so that he can utilize his time for the optimum production. See, there are a lot of now sensors which are coming because the plants who are old 25 years, 30 years, 40 years, it's not possible to altogether go for the new digital sensors, but the existing sensors too can be utilized, or there are sensors which are coming known as pervasive sensors. So those can be put into the plant to take those data to the owners. Now owners here is maybe a maintenance engineer from electrical, from mechanical, from instrumentation side, from process side, and some of the data to the senior management. Now the most important part is here for double IoT. For a process industry, when they are selecting the solution for that, we have heard that people have come up with a lot of things. Now here we have to think is whether we want to have a technology or whether we want to have a solution to resolve our problems. What we have done at DCM Shriram is we have done this exercise internally to first of all find out what are the pain points for the process people to run the plant. Unless we are able to address those pain points, all this technology is just an ornamental feature. It's not going to result in the uninterrupted plant operations or a delighted employees. See, a maintenance guy should not be like that 8 hours he is continuously with the machines. He should be able to spare time to make the strategy how to optimize the plant operations. So these are the 5 questions, and I would like to just give you the insight of each and every question. Now, the first question is the data analytics solution designed specifically for process manufacturing, and can it handle time series data and intricate process manufacturing problems? Why this is required is, now I tell you, suppose there is a wind turbine. There are historians collecting data across many different protocols used by multiple vendors across a disparate array of equipment, all of varying ages and implementations. Now these systems typically produce data at speeds and volumes that other industries would find dizzying, and at uneven intervals that can confound conventional analytic solutions. All this data needs to be cleansed to be useful. I just tell you, a lot of things are coming up. Now suppose in a process plant, if I take a typical case of an fertilizer ammonia plant, the production varies from the ambient temperature. We are doing the cooling of the motors through the cooling water. If the ambient in Rajasthan is like 47, 48, the cooling water temperature goes to 31, 32. The production's levels becomes low. But the same plant, same motor, same water, but the ambient temperature goes to, let's say, 25. The cooling water temperature also goes down. Now the winding temperatures which used to cross the limits in the summers, people are comfortable in winters. Now how do this analytics should provide a solution? It should be able to correlate all the data of what? The airflow, the cooling water flow, the cooling water temperature, the winding temperatures. If all these are correlated by the analytics, then only it is useful for the process person to decide how much intake of airflow a turbo motor can take and how much production levels they can reach, because there is a binding, there is a limitation that binding temperature should not go beyond a certain temperature limit. So my dear friends, what I am trying to here emphasize is the analytic solution should be able to correlate all those data and should be able to give a proper solution to the process owner. The second question is, does the analytic solution rely on your experts or its experts? This is a very, very vital question. Every analytic solution provider, they have a deep knowledge of their own system. But do they have the expertise of your process? The answer is no. They have to first sit with the process guys, even though the production process is same, but every plant, it varies. You have to understand the conditions. Is it maybe the same ammonia plant may have a high pressure systems, the plants which were commissioned in 70s, and now the levels have gone down. So the experts have to be, in a way, the analytic solutions for process manufacturing should put power into hands of the people who can most efficiently create the most positive outcomes. That is very, very important. The third part is the analytics vendor more focused on the problems being solved or technologies involved? Now, here what I am trying to tell you is, the emerging technologies like we talk of big data, predictive analysis, machine learning, deep learning, cloud computing have eclipsed the narrative of benefit and the impact. The capabilities of these technologies have surpassed our understanding of the best way to get value from them. Rather than discussing why we should adopt a particular innovation, the conversation focuses too often on what technology to use, often with more enthusiasm for technology than the actual benefits. This is somewhere the people are lost. They will tell you, like when we go for purchase of a mobile. Now, if a young man purchases a mobile, he sees the different features. And a person of 50 years age, he sees the feature from a different angle. Just think of a process industry which is running for the last 40 years. What kind of analytics that company should have? It should be able to address the problems, not like a slim monitor, a good graphics, good colors. This is not going to end your problems. The next one is, does the analytics solution require you to move, duplicate, or transform your data? Here it's very important. If you take out or transfer a money from your bank, it gives you whether you want to download the transaction as PDF or an Excel. It means what it's doing is, it's consuming a space on your computer. You have to save that. If the same thing is being done by the analytics solution provider, you can think of that the same will be stored in your operating workstation. Means what? The hard disk capacity is going to be utilized. So we have to be very careful, my dear friends, when we are going for an analytics solution provider, that it should not duplicate or transform your data. It should be able to give you the results out of that. So users achieve meaningful results when they can focus on data analysis instead of data collecting and processing. And the last is, can the solution help your engineer work as fast as they think? See, I tell you, the process engineers, the analytic solution should make it easy for engineers to distribute their work and provide a central place where employees can work together to leverage each other's expertise and information. For example, one person might know a certain set of process data really very well, and they know how to clean and transform the data, while another person might know the SAP system really well, and another might be an expert with maintenance system. Analytic solution should make it easy for engineers to distribute their work and provide central place where employees can work together to leverage each other's expertise and information. So these are the 5 points which I feel is very, very important when we select, because you must be seeing it, it's altogether different angle of looking to the IIoT. Unless these points are satisfied, the investment which we are planning towards IoT will go in vain, unless these points are addressed too. Now, how these can help us? I was just giving you an example of cooling tower. Similarly, the compressors, similarly the motors. Now, I feel there are the 3 points where the equipment, the IIoT can really help us out, is the predictive analytics. We should be able to see, in a power plant, there's a turbine. We have the online trending of the vibration, eccentricity, differential expansions, or other data are simply available to us. But do we have a kind of a solution where the analytics can show you that, see, the vibration trend which is going on in the bearing, the front bearing, is going to be such a level in another 10 days that you need to take a scheduled stoppage of the turbine. Rather than tripping a turbine is not simply tripping a power plant. The end user, the load consumer is also going to trip, the thermal stresses. So it should be able to address that problem. It's not simply the trend. Second thing is condition-based maintenance. Normally what we do is, the present 95% of the plants, they are running the plant run to fail. We are not going to stop the plant unless it fails. So that particular thing has to be changed. From run to fail, we have to come to the condition-based maintenance, not the schedules interval also. Sometimes say, okay, the turbines, every 5 years we take a shutdown. A boiler, every year we need to take a shutdown. Maybe the statutory requirement is there. But looking to the condition we should take, not to the number of hours also. We have the parameters in front of us now for the equipment health. Third is the real-time equipment optimization. That is very, very important. We are running a plant, we are sustaining a plant, we are sustaining the production, but are we doing the optimized operation? That is the point, food for thought. And now, for any IoT initiative to succeed, the company needs to focus on 2 important things: identify the business goals, identify the team and organization adjustment necessary to reach those objectives. Anything which is measured can only be controlled. So we need to measure each and every measurement of an equipment which is going to stop that machine forcefully. Now, the value is very important in case of the big data. Is the measurement, is the data available, is of any value to me? It is adding any value to running my plant. Now, as it is said that it's a good fencing for good neighbors. So, IT and OT should have a clear-cut benchmark of where the area of IT starts and instrumentation stops. So it is important to recognize these differences and accommodate unique needs of each. Now, the way forward which I propose is that first of all we should understand the concept and what are the actual benefits which are going to be accrued. We have to conduct an internal meeting and note down the pain points. What are the possible solutions? It's not essential. You will find, and what we have done at DCM is, not everything requires IoT. There are some of the control loops which can be optimized. Then we should conduct a workshop either with a DCS vendor or a double IoT consultant. And most important thing is we should appoint a leader for the IoT who will take this way forward. And the another important point is the management buy-in. My dear friends, all of us know that if a bearing fails, the management will not take a second to approve the replacement of the bearing. But if you go and ask that I want to change my operating workstation operating on Windows XP to Windows 10, he will say, please wait, the machine is working. It's very difficult for an instrumentation department to get the management buy-in for changing even an operating workstation, even a PC. So that's very, very important that we should get the management buy-in. And then we can start the trial with the sensor networks, maybe at a smaller scale, and make sure that the solution is backwards compatible with the existing network protocols. That is very, very important, because in one night you cannot change the operating system, the operating platform of the plant. And this is what is proposed. We should do the plant-wide digital sensor networks, instrument assets, deploy predictive analysis software on-premise. I'm again repeating, this is within the complex of a plant. We are not going anywhere to internet. No cyber threats. Then review our work processes. SOPs have to be modified. Then internal IIoT. Why I use word internal is, it is limited to intranet, not to the internet. And once you are satisfied that the things are now working and you need an external help, then we have to go for IIoT. Means you have to connect the system to the internet. On-premises, in-house, and last is the outsourced connected services. This is how I think the things should move when we want to go for IIoT implementation. I think the time is just over. Thank you very much.